Okay, guys, we are in Algebra 2, Mod 8. Today is Tuesday, April 14th, 2020. Again, Tuesday, April 14th. So in the top left corner of your paper, put 4/14/20. The title is just one word. It says circles. When we do each section of notes, this new chapter, starting a brand new unit, a brand new chapter today. We're done with all the rational expressions and equations and fractions we've been working on, thank goodness. And we've got something I think you'll like a lot better, a lot more manageable, very straightforward, and I think easy to graph these pictures. But when we do this, I would love you to divide your paper into 4 sections and do one problem in each block to really keep all 4 questions we're about to draw and graph kind of distinct and separate and in their own little section, okay? Now, just to mention something here before we start today's notes, any of the things I'm about to talk about, you do not have to write down on this pink paper, but go back in time to geometry, and there was a 3-dimensional shape that you guys studied that was called a cone. Everybody agree that looks like a cone that had a certain height, and the circle at the base had a radius, and you worked with 3-dimensional shapes, including a cone. Well, the title of the current chapter we're about to start is Conic Sections. Now, of course, the word conic comes from the word cone, and sections comes from different cross sections we could create by slicing up a cone, let's say with a knife that we had. So if I had a 3-dimensional cone and I sliced it straight across, or maybe sliced it at a diagonal and sliced it up and down this way, you could then look from the side and view the different cross sections we'd create. And by taking a cone and developing different cross sections, we can create all kinds of geometric shapes. Well, there's 4 main kinds of conic sections we're going to study. The words are circles, ellipses, which are more oval shaped instead of round, hyperbolas, and finally parabolas, which we've kind of studied so far in the past. But bottom line is we are about to study different cross sections created from a cone. The 4 main titles or topics we're going to discover and work on and learn how to draw are circles, ellipses, hyperbolas, and parabolas. And we're going to take those one day at a time. So today, the first day of our new unit, you put the word circles at the top, and we're going to draw 1 circle in each section of our paper, okay? All right, first of all, in block number 1, everybody write the standard equation, x squared plus y squared equals 9. And I'm going to tell you right now, that circle that we're about to draw is in standard form, because a circle is in standard form when it says x squared plus y squared equals r squared. R, of course, stands for radius. So guys, bottom line is, go ahead and draw a nice, neat, rectangular coordinate system with an x-axis and a y-axis. And if I told every one of you to draw me a circle on this paper, but I wanted all your circles to look exactly the same, what would you need to know about your circle for your circle to look the same as the next person's circle? Well, wouldn't you need to know 2 things? Think about it. I would need to know where the center of my circle is. And then once I know where the center is, wouldn't I need to know how big to make it by knowing its radius? So guys, put CR for center and put R for radius kind of off to the side here. When I look at any circle, again, a circle is x squared plus y squared equals r squared. I need to know where is its center and how big is the radius. Okay, first of all, the center. Good news. If you look at your equation and it says plain old x squared and plain old y squared, and there's no number attached to those, like look at number 2 here. It says x minus 2 and y plus 1. They've got numbers attached to them. That means the center of my circle is going to be somewhere other than the origin. But if it's just good old x squared and good old y squared, and there's no numbers attached to those letters, well, guess what? The center, of course, is at 0, 0. So everybody go right to the origin at 0, 0. Put a dot and put CR. There's the center of my circle. Now, the radius, of course, is the distance from the center to the edge. Now, all you guys see a 9, so I know you're tempted to go right 9, left 9, up 9, and down 9. Stop that thought. That is incorrect. It's x squared plus y squared equals r squared. What number did you square to get 9? Oh, that number would be 3, wouldn't it? So really, guys, whatever this number is on the right side, you square root it, and that'll be the radius of your circle. So I'm actually going to go right 3, left 3, up 3, and down 3. And when I connect those dots as neat as I can, wow, beautiful. Looks like I used a compass, doesn't it? You got a beautiful circle centered at 0, 0, whose radius is 3. Okay? Everybody slide to block 2. It says x minus 2 squared plus y plus 1 squared equals 16. And I want you to graph that circle correctly. Okay, well, once again, if I'm going to go and graph this thing correctly, off to the side, I need to write down where's the center and how big is the radius, correct? Okay, the center of this circle is not 0, 0, is it? Because it doesn't say plain old x squared and plain old y squared like that last one. The x has a minus 2 attached to it, and the y has a plus 1 attached to him. So you would think the center would be negative 2, 1. Careful. The rule is the center is the opposite of the signs that you see, the opposite of those signs. So if that says x minus 2, my x coordinate's 2, and if that says y plus 1, my center, my y coordinate is negative 1. Oh, so guys, my center is right 2, down 1, put CR. It's always in the opposite sign of the sign that you see in the problem, the opposite way. Now, the radius, of course, is not 16. You don't cut it in half. The radius is not 8. You square root that number, because what number did you square to get 16? Our radius would be 4. So go to the center of your circle. You're going to go left 4, right 4 from the center, up 1, 2, 3, 4, and down 1, 2, 3, 4. And connect up your dots and draw a nice, neat, beautiful circle looking like that. Okay? Let's go to block 3. This isn't so bad. Uh-oh, freeze. There's something going on here. Notice up top, there was no number in front of the x squared and no number in front of the y squared. On my second problem, there was no number out in front of that parenthesis and no number in front of that one. All of a sudden, we get to this problem, and there's a 3 in front of that parenthesis and a 3 in front of the y squared. We do not want a number in front of the x squared and the y squared. So sometimes, like on this one, we're going to have to manipulate the equation a little bit just to get it into standard form. So since we don't want those 3's there, I'm dividing that whole side by 3 and that side by 3. Whatever I do to one side, I got to do to the other. So in essence, by dividing everything there by 3, the 3's will all cancel, correct? giving me x plus 1 squared plus y squared equals, on that side, 12 divided by 3 is 4. There, look at it. My circle is now in what's called standard form. So when I go to draw it, first question, of course, is where's the center? Oh, it says x plus 1, doesn't it? What's the opposite of plus 1? Negative 1. And notice it's just plain old y squared. That y doesn't have a number attached to it, does it? So my y coordinate's 0. So the center of my circle is right there at negative 1, 0. What's the square root of 4? Well, of course, my radius is 2. So guys, I'm going to go right 2, go back to the center and go left 2, go back to the center and go up 2, go back to the center and go down 2. And you got a nice, neat circle centered at negative 1, 0 that looks like that. And the last problem on the front of my paper, there's one more on the back because there's a special technique you got to use on one of these. Once again, there's a 4 there, and you notice a 4 there. By the way, if that was a 4 and this was, let's say, an 8, oh, and the numbers were different, that's going to make it an ellipse instead of a circle, and that's what's going to be happening tomorrow when we study those. So for today, if there's a number in front of the parentheses, we don't want that number there. We're dividing both sides by, in this case, 4. The 4's will all cancel. We got x minus 1 squared plus y plus 3 squared equals 8. It's in standard form. The center is, okay, careful, it says x minus 1. What's the opposite of minus 1? 1. It says y plus 3. What's the opposite of plus 3? Minus 3. So for this circle, I'm actually going to go what? Right 1 and down 3. So there's the center of it. And as I look at this and say, well, how big is the radius? Again, the radius is not 8 and it's not 4. You don't cut that number in half, you square root it. Now that's not a perfect square, so when I hit my calculator here and do the square root of 8, it actually rounds off to 2.8 to the nearest tenth. So I'm actually going to go up 2.8, down 2.8, right 2.8, and left 2.8. Draw my circle. Supposed to be as neat as possible. Should look like a perfect circle. And you've got a circle that's centered down there in quadrant 4. Okay? And then finally, the only time this gets a little tricky, I'm going to flip to the back of my paper. I've got a big star by this last problem. X squared plus y squared plus 6y minus 4x minus 7 equals 0. That looks crazy. It certainly does not look like it's in standard form. What do we do to this? Because there's going to be one of those on the ACT, I guarantee it, towards the end, where they ask you, how big is the radius of that circle? And you're looking at a big jumbled up algebraic mess, correct? Well, watch this. Here's the trick. Pay attention. Think with me. Don't look at your phone or do other things right now. Focus on what I'm about to do and listen to my explanation. When you've got a mess like this, and you have to get it into, quote, standard form, the first thing you want to do is group your families together. Here's what I mean by that. Obviously, I have an x squared, and if I asked you what's part of his family, wouldn't you agree that that minus 4x is part of his family because he has an x in him? So x squared minus 4x, and then leave a blank space, plus, and then go to your next family. Well, my next family involves the letter y. I've got y squared plus what? 6y. I'm going to leave a blank space. And do you guys agree that that minus 7 doesn't have an x and it doesn't have a y, so it doesn't belong with either family, so he gets pushed over to the other side. So the minus 7 is going to get added to the other side and pushed out of the way, giving me a 7 on the right side. And what you've got to do, remember from earlier this year, hopefully Mr. DeMarco taught you, I know he did, I remember helping some of you with this, a process called completing the square. Remember that process? Your job was to take the middle number, cut it in half, in other words, divide it by 2, and then square that answer. So if you take -4 and you divide it by 2, that gives you what? -2 squared, well, -2 times another -2 gives you +4. And remember, this is an equation, so whatever I do to one side, I got to do to the other. Look at your second family. Take the middle number and divide it by 2. What's +6 divided by 2? Well, that would be what? 3. And 3 squared, you're supposed to square that number. 3 squared would be 9. And whatever I do to one side, I do to the other. So cleaning this up, guys, this right here is now a trinomial, isn't it? It's actually called a perfect square trinomial. And you are going to break it down into a binomial squared. Whoops. Now, how do you know what to put in there? You put in there whatever you got when you cut that middle number in half. So this is going to be x minus what? 2 squared plus, and then take this trinomial, this perfect square trinomial, and turn him into a binomial squared. And what goes in there? Y. And then what'd you get when you cut +6 in half? +3. And on that side, you had 7 + 4 + 9, and you get 20. Oh my gosh, I did it. Now, you don't have to graph this one. We were just trying to get it into standard form. But the center would be where? What's the opposite of -2? 2. What's the opposite of +3? -3. And the radius would be whatever the square root of 20 is, which when I did it on my calculator was 4.5. So you can take an algebraic mess, manipulate it by putting the families together and completing the square, and end up turning it into a circle that's in standard form. And you can tell how big his radius is and where his center is located by successfully getting it into that standard form. So guys, when you try your homework tonight, you've got 5 problems. The first 4 problems, you're just going to draw your circles nice and neat. So put your center in the correct spot and draw the correct sized radius. And then when you get to number 5, just like when I got to number 5, you're going to take this mess, put your families grouped together. You're going to complete the square on each and try to get it into standard form. And so all you've got to do there is try to get it into standard form, but you don't have to graph that last one. You'll graph the first 4 and get number 5 into standard form, okay? So guys, x squared plus y squared equals 25. X plus 3 squared plus y minus 2 squared equals 12. 2 times x plus 1 squared plus 2 times y minus 4 squared equals 18. 5x squared plus 5 times y minus 2 squared equals 30. And then finally, x squared plus y squared plus 4x minus 8y minus 10 equals 0. Those 5 problems you're going to work on today, tonight, tomorrow morning. I don't know, but today is Tuesday the 14th. So just as we've continued with our routine so far, these 5 problems would be due tomorrow on Wednesday the 15th by 12 o'clock noon, okay? Great job. Tomorrow we'll go to our second conic section called ellipses. We'll see you then.